No it don't! No it don't!
If I were to give you a question like this, I'll start off easy. Just an easy question, and I'll show you how calculus takes an easy question and twists it around to make it super complicated. X squared minus 4x, I gotta think in my head to see where, minus 5 equals to 0. It's gonna say find the root, or find the roots of the equation. Go. Find the roots of the equation. You should be able to do this in your head. Since most of you are going to college and universities, you should be able to do this in your head. Jasmine, you did that? Wait, what's your answer? 5 and negative 1. What did you do? Oh, common. What? You factor, you mean? X, so that gives you minus 5 plus 1. X equals to 5 and negative 1. Correct. Easy. See what this really is? This shape is really a parabola. This parabola has an x-intercept of negative 1 and 5. It faces upward. So again, I'm going to play the guessing game. I'm going to say this is my parabola. This is called the roots of the equation. That was easy. What if I were to give you this? I'm going to start off with a shape. Actually, I'll start off with the equation. Y equals to x cubed minus 2x minus 5. Okay. I'm going to ask you find the roots. There's actually many ways of doing this to find the roots of this. One way is you can sit here all day and plug in and use synthetic division and see what number works. But in reality, synthetic division only works if your number is a whole number. You can sit here all day, plug in, I guarantee you will never get a whole number. So, the question is, how do you actually solve for this if synthetic doesn't work? Grab your calculator, let's do this right now, and use your TI-83 and find it for me. 2.69, close. So if I were to graph this, I hit graph, and I know, look at this, it's right here. There's an x-intercept right there. If I were to just look at the trace, I would guess it's about 2.1. But it's not accurate, so I gotta go second, trace, and I go to 0. And it's gonna say left bound. I take my little mouse, I move to the left of that, right there, I hit enter. Then I move the cursor to the right of that, I hit enter again, I'm gonna hit enter again for guess. And right there is 2.09455. Write that number down, please. 2.09455. 15. I want you to write as many digits as you can. I'm going to show you what we're going to do with this in a second. See, that was easy. If you have a TI-83. And this was done by using TI-83. The problem lies in, well, what if you don't have a TI-83? So I'm saying, no, I don't have a TI. Can you solve this without using TI-83? And the answer is yes. And Newton came up with doing this. So I'm going to show you his method. And this is a method that's taught in every college university because they want to devote one section to him. And this is his big moment. So I'm going to draw the graph on here, please. So I'm going to draw the graph, exactly what it is. So draw the graph on your paper. I'm just going to draw it and ta-da, there it is. I just drew it. The way Newton's method works is this. It's a very simple concept. He says, what if I were to pick any random point? I don't know where the answer is. So I'm going to choose a random point somewhere around here. We'll call this 1. Okay. So Newton says, I'm going to choose a random point. We'll call this x1. I'm going to go to x1 right here. So x1, this would be y1. Okay. Even though I know this is not an answer, I'm going to draw a tangent line. at this point. So draw a tangent line for me, please. So we're going to draw a tangent line. And the tangent line is kind of close to the answer. See? It's kind of close. But not exactly correct. So this is known as x2. If I were to do a tangent line, that would get me closer to the answer. But now, x2 will correspond to a point somewhere up here. We'll call this y2. If I were to do the tangent line of y2, would you agree that y2 is actually even closer? Or it gives me a better answer, see? x3 now. Hey, the more tangent lines I do, the more accurate it gets to it. So I keep doing this method over and over again until I hit the answer. See, I start with 1, and then I take the tangent line. It doesn't give me an answer, so I take the tangent line. I keep doing this, so his method is given by this formula. And I'll go over this formula with you. So it says it's going to be xn plus 1 equals to xn minus fxn over f prime xn. We'll just start this, and this is known as Newton's method. It's a really, really simple idea, but it's really powerful. So it says, choose any random point. Doesn't matter where you choose. I'm going to take the tangent line of that point. And the theory behind this is this: the more times I do the tangent line, the closer it gets to my actual answer. So for here, I'm going to say, my first guess, I'm going to say, let's do this question again. X cubed minus 2x minus 5 equals to 0. I don't know where my answer is. I'm going to say, use Newton's method to find the root. To find the root. Okay. Let x1 is your first guess. I'm going to say let x1 be the number 1. Because I don't know where it is, I'm just going to assume. In every question, most of the time, I'll give you what x1 is. So we're going to do this. This is a guess. This is known as a guess. It's never going to be right. So I'm going to use this method to take my guess and make it better. So watch what I'm going to do. I'm going to look for something called x2. See? x2 will be even closer than x1. So watch what I'm going to do. I go x2 equals to x1. I'm going to plug in the formula. Minus f of x1 over f prime of x1. So x2 really is using what x1 is into the equation. So plug it in, and I can work with you. So it gives me 1 minus. Here's my equation. So f of x1 really is, so somewhere on the side, let's do f of 1 equals to 1 cubed minus 2 minus 5. That gives me 1 minus 2 minus 5, that's negative 6. So it'll be negative 6 up here. Now I want you to go ahead and do f prime of 1. I'm going to pause it, let you what I'm going to do. So if you're lost, watch what happens. So this is going to be 3x squared minus 2. So this is going to be 3 times 1 minus 2. Well, that's equal to 1. Whoa, what's going on here? I did something wrong. That gives me 1. So go ahead, plug it in and solve it for it, please. 7. We're going to do this again. At x3. Now we're going to use 7. So it'll be x of 2 minus f of x2 over f prime of x2. You're going to do it, and slowly all the answers will merge together. So try x3 for me, please. So what happens when I go x2? I go watch x3. So it gives me 7 minus f of 7 over f prime of 7. Did anyone get an answer for x3? 4.7. So you notice how my answer is slowly coming towards it. We're going to do this again. Now, how many times must you do it? You're going to do it until the first 3 decimal numbers repeat itself. So let's do x4. And I bet you x4 will be even closer. You don't, sometimes it may take you up to 6 iterations. This is known as iterations. So when they say on exam, do up to 4 iterations, which means you got to do it 4 times. So x4 equals to x cubed minus f of x3 over f prime of x3. Go ahead and do it. And I bet you it's going to be around 2. So if I did with x4, I hear the answer is 3.3? 3.35? So you notice how I started with 7, and then it's going to hit 4.76, and then notice it's again 3.3. The numbers are not repeating yet. If it's not repeating, we do it again. So now we do x5. And slowly it's going to narrow down. See, it's changing less and less. So this will be x4 minus f of x4 over f prime of x4. So if I look at x5, I hear the answer is 2.5. So you notice it's getting closer and closer to my root, and the change is getting smaller and smaller. So I know I'm about to hit it soon. One more, and I'm going to stop right there. And if you do this next one, I promise you it's going to be around 2 point something. 2.17? So I hear x6 is around 2.17. If I keep going on and on and on, it's going to hit around 2.09 and repeat itself slowly, because the change is getting smaller. This is the power of Newton's method. If you choose the wrong number to start it with first, you got to do a lot of iterations. I chose 1 to start off first, because it's, and you can see it's huge. There's a lot of gaps. I'm going to give you another question where you only have to do it 3 times and the answer will repeat itself. Try this. Hi, question. What's the purpose? To find the root without using a graphing calculator. Why can't we use a TI-83? Because on the exam, they're going to ask you to use Newton's method to solve the root. Hi. Hi. Oh, I just give you a random number. The question will give you a random number started. No, the question will give it to you. Try this one. This one's a lot easier. Example 2. Find the roots correct to 6 decimal places. So in other words, you can't stop until 6 decimal numbers are repeating. And it's going to say you're going to force to use Newton's method. Here's your question. Cos x minus x. Oh, sorry. Cos x equals 2x. And I'm going to tell you the first number. Let x1, I'm going to be nice. I'm going to give you an answer hint. It's super close to 1, but not exactly a 1. Find up to 6 decimal places, and I promise you it won't take you that long. Go. I'm going to pause it, let you have a crack at this. So if you need a hint, I want a root, so I have to equate it to 0. Cos x minus x equal to 0. Okay? So now, I know I'm using Newton's method, so I need x2. x2 equals to x1. Look at my formula if you're lost. Minus f of x1 all over f prime of x1. So you notice Newton's method is it takes your previous answer to get a new answer. And you keep doing this over and over again. x2, all the decimals. You keep all the decimals, 6 decimal places. Whoa. Make sure you're in the right unit. So if you did this correctly, you should have 0.750363887. X3 should be 0.739112289. I want you to stop at X4. Do X4 for me, please. Correctly, X4 should be 0.739085513. And notice the numbers are repeating. Hi.
So for example, when you're plugging in to the original equation, you're plugging in, for example, 0.75. To keep the answer to the
You have to keep the whole entire thing. No, use the whole entire thing. Use the whole entire thing.
Not for that, when you're plugging in the answer into the original equation.
Yes. Okay. Guys, you should have this. And if you did it correctly, notice one thing. The numbers are repeating itself. So I know with fact, certainty, that the first three decimal places is 0.739. If I do this again, I'm going to have more repeats. The question is, how many times? On exam, you probably do about 4 or 5 times. Now let's graph this and see if my method is right. Take your TI-83 out, and I want you to graph this and see if it's the same x-intercept. Cos x minus x. You may want to change your Windows mode. Okay, I'm going to change my Windows mode. It should be in radians. And my Windows, I'm going to say this is going to be from 0 to 2 pi. Because when you graph trig, it should be from 0 to 2 pi. Where's my pi? Right there. And my min, well, I'm going to say -5. My max is going to be 5. How did I know? I don't. I'm just playing around with this. I'm going to hit graph. And right off the bat, look, there's a point right there. Go hit the second calculate button and see if it's 0.739. Because I predicted it should be that from Newton's method. Second, trace. I go to 0. Left bound, I take my little cursor, go to the left. Enter. Go to the right. Enter. And check that out. Matches exactly. And using Newton's method. I'm going to pause it and let you... Sometimes the question is worded in such a way that you don't realize it's Newton. It's going to say use Newton's method. No, you're going to show you why. Use Newton's method. If we use your method, we'll all end up in summer school. Come on. To find root 2 of 6. Yeah, it's the 6th root. At x1 equals to 1. See, the problem with Newton's method is this. In every question I give you so far, it has to be x. How do you turn this question so that it has x in it? That's actually where you have to think about it. See, in every question I give you, Newton's method has an x. Nope, no antiderivatives. Sorry? Nope, close. Question is, how do you turn this into an equation? Because it has to be an equation equal to 0. X, keep going. X. Anyone figure it out?
X plus root 6.
X, no, not plus. Minus. Nope. 2. And there's a number here. Nope. What number goes there? 6. Because this is the same thing as saying this. Because when I solve for x, I get this. So now, use Newton's... See, this is why it's tricky on exams. Hi. What, how? Because if I ask you, for example, root 4, would you agree, is the same thing as saying x squared minus 4 equals to 0? Because if I solve for x, I get x squared equals to 4, x equals to root 4. 2 fly? So, now, I'm not going to do this, but you can actually do this on your own now, because here's your equation. I just hit Newton's method again at x equals 1. So Newton's method is another way to approximate any answer you want. And by the way, your calculator uses Newton's method. There's a chip program in there. So when you punch in root 6, what it's actually doing is Newton's method over and over again until it repeats itself. All your calculator, when it says find the root or whatever, your calculator uses Newton's method. There's actually a chip in there, a program that programs Newton's method. And that's what your calculator does. So that your TI-83 uses the form of Newton's method in their calculations. When you hit the 5th root of 2 on your calculator applies Newton's method to solve this. Your work, Page. Oh, the answer is, if you 1.12 something around there. Page 297. Numero. Numero 5. To 10. Actually, no, I want you to just do 5 to 12 and that's it. Hi. Is it that hard? No, it's just a lot of work over and over again. 5 to 12. Sorry? Oh, the problem before? This one? The answer is x6 equals to 1.122462205. There is, but I was going to focus on the positive version for now. Okay?
Wait, what? Oh, for this one.
Hi. Oh, a lot of you say, Mr. What's on our test because I